So I thought today I would start with just a little review or overview of your toolkit. So what is the toolkit you need to bring with you to your exam to conquer circle geometry? So let's have a look. So what's in the toolkit? Well, there's some familiar faces here. There's line from center perpendicular to the chord. There's angle at center equals twice angle at circumference. There's angles in the same segment. You've got exterior angle of a cyclic quad. You've also got in your toolkit your converse theorems, which help you prove something is, for example, a diameter, or prove something is a cyclic quad. So the converse theorems help us prove that. And then the other converse theorems would be proving tangents. So there's one converse, and then this would also be the converse of the tangent radius. So just take a look through that, maybe take a screenshot if you want. Give me a thumbs up if you feel vaguely familiar with the full toolkit, because this is the toolkit that you want to carry with you into your exams. I can expand it a bit. Maybe if you want, let's see if I can make it as big as possible. Too big, too big. Come back down to size. There we go. Okay. So maybe take a screenshot if you want, one page kind of summary. Okay, then the best practice is to do the questions. And so let us start with the question over here. And what I want to suggest with all exam questions is you take the time to introduce, like meeting someone new, always good to give a little bit of an introduction. And so let's go, and initially these are points on the circumference. And so my brain starts to think about cyclic quads initially. I also have G1 is x plus 20, which is down here. So that's where that angle is hanging out. And we have H is 2x plus 10. That's down there. And then we also see that DE is parallel to FG. So when I see that, I need to remember that there are certain angle relationships that are involved with parallel lines. So I want you to try and answer this 6-mark question. See what you can do yourself. I will answer questions and give tips as needed, but I want to see what your understanding is like by yourself initially. So see what you can do. What is DEG to start with? And what are your reasons for determining what you determine? Yes, Karabo, I agree. I think you're onto something. Karabo is saying alternate angles could be important, and that this is alternate to that. So what does that make DEG? So the reason is alternate angles, DE parallel to FG, but what is DEG actually equal to? It's going to be x plus 20. Yes. Okay, so that's part one. That's 2 marks in the bag. 1 mark for this, 1 mark for that. The next thing you have to do is calculate the size of DHG. Now, DHG is already there, but we want to know exactly, like, is it 70 or 90 or 120? And what are we going to need to do to figure out that? Yes, Kristen, I agree. H is supplementing to E. Let's have a look. Wow, Fedeko, well done. What is the relationship between H and E? Why are they supplements? Can you tell me? Yes, opposite angles of a cyclic quad. So it might have snuck in, but if you look at this, this is actually a cyclic quad. So you know that these are, they're not equal, but you know that they add up to 180. So x plus 20 plus 2x plus 10 must equal that. And the reason is opposite angles cyclic quad. But now you still need to find what x is and then find for me the final thing, which is DHG. So let me know in the chat what you think that's going to be. I'm going to turn my lights off. I get x is 50. I get x is 50 because we get 3x plus 30 equals 180. Yeah. Now, what is DHG going to be? Well, whatever x is, I suppose I would just sub it in. 2 times 50 is 100, so that must be 110. So the answer, what a lovely 4 marks in the bag. Yes, Kayleen, I agree. So what, yeah, thumbs up if that felt okay, thumbs down if it felt a bit bleh. Okay, awesome. Let's move on to part 2. So let me just make this a bit smaller because it's looking a bit like it's taking over the show here. And let me enlarge this if I can. No, I don't want to do that one. I want to do, where's the question now? Not that one. Well, let's do this one. Move this out the way. So here is a 7-mark question from an old exam. Let's introduce ourselves. So O is the center of the circle. So I know there might be theorems with the center of the circle. CDE is a tangent to the circle at D. So that's point of tangency. DB bisects ABC. Okay, this is, the wording is a bit thing. Where is ABC? So ABC is here. And what they are saying is that the line that comes over here, it's cutting this in half. Now, visually, it doesn't look like that, but that's what bisect means. And it says, let B1 be X. Now, if it's cutting this in half, then actually it means if that one is X, then that should be X as well. And it's quite important to recognize that at the beginning, because if you don't recognize the bisecting of ABC, this question becomes harder. Okay, so I've introduced myself to the question. I've put any important information I need to on the drawing. Try and answer for me, how would you prove BC is parallel to OD? How would you prove BC is parallel to OD? Maybe think about what are the ways we prove something's parallel. So this needs to be your toolkit. How to prove parallel lines? What are we looking for? 3 ways you can do it. One is to show alternate angles equal. you can say corresponding angles equal, or you can say co-interior angles supplementary. And normally they go with the Z, F, or C shape. So in order to figure that out, you need to do some more maths. It's 4 marks. So what would your first step be? So Chris Dunn has said angle C equals EDO B1 plus B2 alternate angles. Okay, the thing is you can't assume these are parallel. You have to actually use other theorems to show they're parallel. So B1 plus B2 equals O1. Oh, okay. I think I know. How would we find O1? What is O1 going to be equal to? Maybe I should put it like that. What is O1 going to be equal to without using alternate angles? What theorem can you see? Okay, Andile, yes. Andile has spotted an angle at the center. So if I use this, and then I go to here, O1 must be 2x because of angle at center equals twice angle at circumference. So that would then be 2x. Ooh, or you could say using exterior of triangle. So Krista and I agree, you would just have to, into that, you would then first have to say, look, this and this are radii. And so this is x over here. So D1 is x because of radii. And if you got that, you can then say that O1 is 2x by exterior angle triangle. Yes. So that's another way of doing it. Which of the 3 ways are we going to use to prove this is parallel? Actually, there's 2 ways you can do it. I can see 2 ways. So I would say BC is parallel to OD, but what would my reason be? Well, if I know that that is 2x, and I know that that is 2x, you would say corresponding angles equal. The other way to do this would be to show, if you've showed that this is equal to that, you could say alternate angles equal, because both of those are x, or you could say both of those are 2x. And both of those would prove that. Okay, so that's how we do this one. So we've done that one. I now want you to try and do this one. Show that C is 90. How did we find B2 is x? Josh, at the very beginning, it said that DB bisects ABC, which means cut in half. And it said let B1 equal x. So if B1 is x and this line cuts it in half, that must be the same. Okay, I'll give you a bit of time for the next question. Now remember, actually, you have just proved something. So let me put that on the, you have just proved that that line is parallel to that one. So let me not forget that, just in case, because once you proved it, you proved it. Now you can use it. So what I'm seeing in the questions is that ODC is 90, and that would be tan perpendicular radius, tan radius. So we know that this one is 90. Now, how do we prove that angle C over here is 90? How are we going to do that? What logic? Well, actually, these are between two parallel lines. So yeah, so this has to add up to 180. So you say that angle C plus 90 must equal 180, and that's because of co-interior angles. And the parallel lines are BC parallel to OD. But then C must be 90 because it's between two parallel lines. So what are the co-interior angles? So the co-interior angles are the angles between the parallel lines. So if you imagine, let me color in this. So this one over here and this one over here are between, it's looking a bit more like a crime scene, but you can see the parallel lines going there. CD is standard, O is center, yes. Perfect. Nashon, your hand is up. Can we answer a question for you? Can we unmute Nashon? Can you hear me, Nashon? Or maybe the hand up by mistake, but okay. Can we unmute? Let's try to do that. Nashon, can you hear me?
Yes, sir. Good day, sir.
How's it going?
I'm good. So I wanted to ask, how did you prove that D1 is equals to B2?
How did I? D1 is equal to B2.
Yes.
Good question. Okay. If we look at this, let me get rid of some of the stuff here. The main thing that I noticed was that this is from the center of the circle to the edge, which is a radii, and this is also a radii, which means that that angle, that side is equal to that side. Now, because this is an isosceles triangle, that must be x. Does that make sense?
Yes, sir.
Okay, fantastic, thanks. All right,
so,
well, then, yeah.
So do you have a lesson on the cos and sine rule?
I do. Kia, can you maybe find the link to that and just pop it in the chat? There's definitely, I did a whole series. I did 6-8 lessons on all those things. So there's plenty of content on that. Cool.
Okay, thank you, sir.
Pleasure. Okay, so what we have here is, let's just pop one more question before we go to the break. Let me see if I can just make this one nice and big. And here is, let's let you guys loose on this before we go to break time. So in this question, O is the center of the circle. Okay, so we have a center. We have the points on the circumference. We know that BOD is a diameter. So BOD is a diameter. And we also know that, but that's it. We know A1 is 51. So A1 is 51 is here. And B1 is 29, which is down here. Let's start. Can you find for me O1 and can you find for me A2? Let's start with those two questions. So what do we think O1 is? What do we think A2 is? I see a lot of students are jumping all over O1 because I think they notice it's the angle at the center and they say it's 102 degrees, which I would agree. Okay, so that is 102. what about A2? Where is A2? A2 is sitting up here. So what are we going to get for that? Well, I agree that there's a diameter involved. So many students are pointing out that this has to be 90 degrees because of the diameter dB. So what we could say is that DAB is 90, and that would be angles in semicircle. And then because we know that A1 is 51, we know that A2 is 90 minus 51, which is 39. And so this would be 39 degrees. Okay, let's do the next two. Can you find me the size of D, and can you find me the size of ACO? That's the next two questions. D is up here. What is D going to be? Oh, it's a triangle. And then that would be so what do we get for D? It's going to be 61. Yeah. Okay, ACO, and it's 3 marks. Now, where is ACO? ACO. ACO is down here. Let's get rid of that red dot. So we want to find C1, essentially. ACO is the same as C1. And there's a couple of ways we could do it. I'm going to give you some time because it's 3 marks, so it must require some thinking in terms of processing. So you know that C is equal to D. For Tejo, yes, I agree that C is equal to D. So this over here is equal to the whole of this over here. The problem is you want to know only the red dot part. So that's what you have to figure out. How can you get just the red dot part? There's a couple of different ways you could do this. But it depends on what you notice. So the one way of doing it would be to say, look, I can work out what that is. I can also work out what that is. I can work out what that is. Therefore, I can know what the red dot is. So just using triangles. Or you could recognize that what is this over here? And what is this over here? Well, those are both radii, which means you should be able to work out what that angle is over there. And if you know what that is, you should be able to get the red one. So I'm going to do that, but you could have done it either way, and the answer will get there eventually. So we will say angle C2 is 180 minus 102, but then I need to divide by 2. And the reasons would be radii and sum of angles in triangle. Now, what am I going to get for C2? I might need some help here. What do I get for the green dot here? So for example, yeah, look, I understand there's different levels, and after the break, I will, you know, I turn up the heat a little bit as we go. So what do we have? 78 divided by 2. This is 39. Okay, now if we know that this is 39, what we also know is that angle C, the whole of C, was 61 degrees by angles in same segment. So that was just the idea of this one over here is 61. This whole thing here needs to also be 61. But remember, I want C1. So all I need to do for this one is I'm going to say 61, which is the pink, minus 39, and I should get 22 degrees. Give me a thumbs up if that made sense. Give me a thumbs down if you are feeling a little bit overwhelmed. Yeah. Okay. Awesome. Well, then we've done a solid half an hour. So what I want is I want everyone on their feet, and I want to make sure that your body gets a break. Even if it feels a bit like random, we know that like if we're relaxed, our bodies just learn better. It's the same idea that if you're hungry or if you haven't drunk water, your body's also not going to learn as well as it could. So we're going to take care of our bodies for a moment, and we're just going to start with 3 or 4 deep breaths. So let's breathe in. Breathe in. Breathe in. One more. Okay, shake out your arms like they're licorice. Want to get nice and loose. Shake out the legs. Okay. And then let's start by just rotating with our arms a little bit. Just a little bit. And as you relax, you'll find that you are going further. Yeah, then shake out the arms again. Shake out the legs. See tricep. Hold that. The other one. Okay. Then let us let's do some small circles with our arms into big circles. And then let's change direction with big circles into small circles. Okay. Okay, so hopefully our body is feeling a bit looser, some circulation, but what we need is some blood to pump in our bodies. And so we're going to do jumping jacks, which go like this. And we're going to try and do 20. And we'll start in 3, 2, 1. Let's go. 2, 3, 6, 7. Halfway. And there we go. Woo. And we haven't played Maths 24 recently, so let's do it. Here are the Maths 24 questions. Ooh, my heart rate is pumping. Can you solve these Maths 24 questions? See if you can nail it. Okay, Karabo has said 8 times 4 minus 8 times 1, which is indeed 24. And Kayleen also gets that. Kitso and Tati have put answers forward for the yellow and the blue. Oh, it's yellow, sorry. So yellow, 9 minus 4 divided by 4. So I've used that, and I've got to 8. And then if I take that and I times it by 3, I get 24. Yep. So Tati and Kitzel, you've both got, let's have a look, 4 times 9. Yep. Well, in fact, actually, Tati did it a different way, but it's also good. What about the blue one? What about the blue one? Has anybody managed to crack the blue one? So Kitzel has said 3 minus 2 gets me to 1. And then 7 times, 1 times 4 times 7. I'm not sure, but I think you're in the right ballpark. Kitzel, I was thinking, 3 minus 2 is the 1. And then 1 plus 7. Wait, no, that won't work. What have we got to do here? So Josh has suggested 7 minus, there we go. 7 minus 3 minus 2. So 7, that gives us 6. And then 6 times 4 gives us 24. Yep, that looks great. And Kitzel, yes, I see what you were saying now. Thanks. All right. I hope that you all feel like you've had a bit of a break, that your brain has had a bit of a mental holiday, that the blood and oxygen has flowed around your body, and you are ready for the second half of the lesson. So let me find the question I wanted to give you earlier. Let's do that one. Where is it hiding? Is it hiding beneath here? There we go. There it's hiding. So let me just, I'll just do it here on the side. And let me just get the thing over here. Oh. Move this out the way. So while we are waiting for this other thing to get off the screen, let's look at what could make a question more difficult. Okay, so I've got that. And all right. So here is another question. In this question, we have diameters of the circle. So let's have a look at them. We have QS and we have PR, such that PQ is parallel to SR. So I should probably just make sure my brain is aware that there are parallel lines here. And it says N is a point such that Q1 equals Q2. So we know that this one is equal to this one. They are telling us to start with. So that's useful. And then it says S1 is 48, which is 48 is down here. Okay. I want you to try and find me the answers for A, B, and C, which is Q1, R, and M1. See what you can do. So Josh, Q1, Q2, tan chord theorem. Let's have a look. So you're saying, is there a tangent? You know what? There's no tangent, I don't think. So you almost had me there, Josh, because this looks a bit like a tangent, but a tangent only touches the circle in one place. So this can't be a tangent, even though it kind of is tempting us. Something that is a little bit hidden is this angle here has a relationship. What type of relationship does it have with other stuff in the drawing? Yes, so we know, so I see Kristen and Fatejo have pointed this out, that angle Q, the big Q, must be equal to 48 degrees because of exterior angle cyclic quad. So that's good and well that this whole thing is 48. But what is the size of Q1? And because earlier in the question they told us that they were each equal, it has to be 24 because Q1 equals 2Q2, and that's given. So this is 24, and that is 24. Okay, find me what R and find me what M1 is. So Obongwe, Emmanuel, or Tile are all pointing out that R seems to have a relationship with Q1. And that relationship is angles in the same segment. And so we would say that R is equal to 24 degrees angles in same segment. So this would be 24. Okay, next we have to try and find M1. So where is M1? M1 is sitting over here. So what is M1 going to be? There's probably a couple of ways we could get there, but what way would you use to get there? We do have diameters as well, I suppose, that we haven't, have we used them all up yet? What is your reason? So one of the things that snuck out of my mind for a second, but I see students have noticed, is what about these things that are parallel lines, right? These are parallel lines. And what shape do I get between parallel lines? Well, it feels a bit like there is an F shape that is not getting the attention it deserves. So I think, oopsie daisy. Let's just take that out for a second. I think students have spotted that this one over here is corresponding to that one over there. So like this angle is equal to, it was a good spot. I didn't see that straight away. So M1 is 48 degrees, corresponding angles. And what is the reason going to be? I mean, what's the parallel lines? It's going to be PQ parallel to SR. Okay, so we've got 6 marks in the bag. Now, what is different about question 10.2.2? So we've got one more, two more question, but I want you to think about what is different about this and what tools do you think we're going to use for this one? So I have to prove that something is a tangent. What are my choices for proving something is a tangent? It's converse something or it's converse something. So it's either converse tan chord or it's converse tan perpendicular radius. I think that I need to look closer because it says M, N, and S. So where are M? Here is M. Here is N. Here is S. So I'm checking. Now I can see a big 48 here, and it's almost like this would be a chord. And I've just proved that that is 48. So that makes me think I should use the converse of the tan chord. So I'm going to say here, M1 equals S1 equals 48. Therefore, ST is tangent, and the reason is converse tan chord theorem. So remember that toolkit that if you have to prove something like a tangent to a cyclic quad, that's what you need to do. Give me a thumbs up if you feel okay with that. Thumbs down if you feel unsure. I think we've got time for one or two more questions. So let's then move on if everybody feels okay. What is the one I want to do next? Let's do this one. This looks like a nice one. Control X. Let's go down here. No, I don't want that one. I wanted, who's the one with the hiding behind here? Here it is. Things are hiding today. We'll do that one afterwards if we have time. Okay, so here is your question. And the first thing to start with is O is the center of the circle. So O is the center of the circle. Maybe give it a nice big dot. These are points in the circumference. So you can see you have a cyclic quad. TOQ is a straight line. And PQ equals QR. Now, they tell us that this is the same as this. And they say Q1 is X. You have to find P1 in terms of X. See if you can do that. Find P1 in terms of X. No question gets away from me for typical. What is P1 in terms of X? Who wants to give us a hint? Or give us an idea? We can do this as a team. My attention is being drawn to R. What is the size of angle R? Or R1 rather, sorry, R1. So R1 is going to be X by radii. So this one over here is equal to this one over here. Then O1 is going to be equal to 180 minus x by sum of angles in triangle. So this would be 180 minus x. And then from that point, it feels like that is an arrowhead pointing like that, which means that P1 must be 90 minus x. Angle at center is twice angle at circumference. So this is 90 minus x. That was indeed sneaky. But remember, I turn up the heat. So as the lesson goes on, I kind of gradually make the questions harder. Now, for 8.2.2, okay, so sorry, this should have been, I made a mistake. This should have been, my apologies. Well done, Tejo. You have spotted my incongruence. This should be 180 minus 2x, because there are 2 x's in the thing. And then when you take 180 minus 2x divided by 2, you get 90 minus x. So that's how I got that. Well done, Futi. Well done. Okay. Now, if I want to show that TQ is this line, bisects PQR, what do you think I'm going to do? Josh, I'll get back to you in a moment. You've said would P equals 90. The problem, Josh, is that TQ is not a diameter. It would need to come, the angle would need to come all the way down. There'd need to be a diameter, and there's no diameter here. So you can't use that like that. So just to go over, I think I lost some people. This is x because of radii. This is 180 minus 2x because of angles in a triangle. And then half of that would be this one over here. What technique do you think I'm going to use to try and show how I cut this in half? What technique do you think I could use? I think I need to show that this angle is equal to x. If I show Q2 is x, then I know that this line cuts it in half. Yeah, Awami, I totally agree. So now the question is, how do we do it? Have a look and see what you can find. What things haven't we used so far that maybe we could use? And I'll get rid of some of the clutter so that you guys can see a bit better. What bits of information might be helpful? I'll give you some hints. Let's see. So you could use, which triangle would you use? Yeah, you could. So you could say, I think Flamelo is saying, you could go, this is 2x over here. But then, Flamelo, what else would you need to use? Because we're trying to get what we still, that's an x. We don't have a 90. We don't. Okay, how about this? Can you guys remember the theorem that says, if you have equal chords, so if you have equal chords, so here and here, right? So here's a chord, and here's a chord. If those chords are equal, they will subtend the same angle. Let's have a look. Here and here. So, for example, if this one over here must be equal to that one over there, it's called equal chords, equal angles. And what I was thinking is that if I know that this one over here is 90 minus x, I think that angle, this one over here, okay, this one over here would also be 90 minus x. Can you follow my logic there? Take a moment to see if you agree with me. Can everybody see that this one over here, it's a bit hidden, but basically that makes that angle there, and this one makes this one here. Yeah. So we would say that angle R1 plus R2. So R1 plus R2 is 90 minus x, equal chords, equal angles. Now, if I know that this thing is 90 minus x, so let's just put in a, Toboko, I'll come to you right now. Is your hands up, Toboko? Let's have a look. Can we unmute Toboko? How are we going to find this angle Q2 using what we've done so far? I was thinking we go 180 minus 90 minus x minus 90 minus x, and then minus x, and see what we get, what's left over. Because isn't that a triangle, like the three sides of a triangle? So let's see, 180 minus 90 plus x minus 90 plus x minus x. So, and then I get, well, that knocks that out, that knocks that out, and I'm left with just x. So this would be x. There might be other ways of doing it, but that's the way that I just thought of right now. All right, last question for the day, and then we call it a day. Show that STOR is a cyclic quad. So we've got all this information on the drawing that we've got, and we need to show that STOR is a cyclic quad. What are the tools we have for showing something is a cyclic quad? So if you want to show something is a cyclic quad, you have to use a converse theorem. And you can either use converse opposite angles of cyclic quad, or you can use converse exterior angle cyclic quad, or you can use converse angles in the same segment. Now, I think opposite angles are going to be quite helpful. Would you agree with me that there is already a cyclic quadrilateral already? And that cyclic quadrilateral is this, 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 and this. So we can say that angle S is 180 minus 2x. So this angle here is 180 minus 2x. Now, once you know that this angle over here is 180 minus 2x, you notice that this one over here, the exterior angle, is also 180 minus 2x. So I'm going to just take these out so you can see them. But basically what we're saying is that, let me use a different color, that this angle over here was already proved to be 180 minus 2x. And I've just used the opposite angles of a cyclic quad to make that 180 minus 2x. Sorry, I'm running out of space here, everyone. Now, if I know those two are equal, then this must be a cyclic quad. So we'd say then STOR is cyclic quad. And the reason is converse exterior angle cyclic quad. Let me get rid of some of the writing. So just to go over the logic I used again before I dismiss it for today, I first looked at the big cyclic quadrilateral, we'll say the yellow one. And using the fact that this was 2x on this side, this had to be 180 minus 2x. This was 180 minus 2x already. And now I have an exterior angle equal an interior opposite. All right, everyone,